Hi, friends. Welcome again to another episode of Beyond the Clouds Edge to Edge Transformation. And speaking of transformation, I got to know Prabakar Sundarrajan during the good old .com days. And he's never slowed down. He's always doing something interesting and exciting. Prabakar, tell us a little bit about your journey, both as an engineer, entrepreneur, and now as a mentor to many initiatives as well.
I was educated in engineering at Indian Institute of Science, Bangalore, and then at University of Massachusetts, Amherst. I did masters in computer science. And after that, my career has been kind of like what I would call this bimodal, where the initial portion was really large companies like Intel, HP, IBM, and then all startups. So totally two different poles. And then I was in the founding team of Exodus Communications, as you know, which is the internet data center company. We probably think of it as Cloud 0.1. And then we co-created a company called Netscaler, and then became the management team along with Jagadish. And then Citrix acquired Netscaler, and I was CTO over their networking group for a few years. And then I co-founded Ankeena Networks along with Rajan Raghavan, my partner. It was a video delivery server appliance. Our claim to fame there being all Apple stores all over the world deployed our Ankeena systems for video and software delivery. So that's neat thing there. And then we decided that we would kind of change tax and start giving back a little bit, which is why we created this company called The Fabric. I'm wearing the logo here. So The Fabric is a co-creation company. What we mean is we identify very large spaces that are ripe for innovation. And then we identify entrepreneurs who are passionate about that space. And then we kind of start from scratch, clean whiteboard, chalk out various things that are happening in that space, the trends, the challenges, the needs, and then create a hypothesis, marketing hypothesis of what might be a play. And then we go and talk to a whole bunch of people, customers, prospects, partners, investors, big companies, possible competitors. We have a big advisory group for The Fabric. We talk to all of them in the industry. We focus only on cloud infrastructure, by which I mean cloud networking, cloud security, cloud storage, and orchestration in the cloud. That's it. It's hybrid and multi-cloud. And you can throw in IoT in there as part of this hybrid edge cloud structure. So that is what we have co-created 12 companies, out of which I think 7 have got acquired, and 2 are still in flight, and 3 went sideways. So the biggest outcome of these would be VeloCloud, which got acquired by VMware, which is a great example of the co-creation. We basically thought, hey, the trends are that applications are moving to the clouds, enterprises are adopting clouds, and enterprises are at the same time adopting broadband in branches. So you cannot have this fixed telco networks just as the enterprise network, wide area network backbone. You got to have much more secure, flexible networking to give access from branches to the cloud with high performance. That was the genesis of the thought process that led to VeloCloud, which established a whole new category called software-defined WAN. So it was one of the 2 companies that pioneered that whole space. And then everybody jumped on that, of course. We call them SD wannabes. So, and then there were at one point, there were like 60 companies in that space. So the whole thing got whitewashed. But VeloCloud truly was one of the two pioneers in the space, along with Viptela, which got acquired by Cisco. VeloCloud got acquired by VMware. Interestingly enough, both Cisco and VMware were investors in VeloCloud. So go figure. So that's a good example where we identified Sanjay Uppal and Steve Wu, who are entrepreneurs who were really passionate about that space, and we brainstormed and came up with this idea and went and talked to a whole bunch of people, and people said, okay, really the key issue is voice over broadband to branches. So we solved that one thing exceptionally well, which just VeloCloud was a rocket ship. So that's a good example of that process. So still in Fabric, still two companies working on it. We are in a very, what I would call is deep touch. It's not an incubation because we are involved in architecture, strategy, marketing, sales, everything in a very, very close basis. So we are kind of like co-entrepreneurs and not just incubators.
Your success is way above the average that you see at an angel investor or incubator. Maybe 20 out of 100 succeed, but you guys have like 80 out of 100, 8 out of 10. Tell me about it. How do you make it happen?
Well, it really started with, I would say, NetScaler in a sense. While at Exodus, we kind of like identified these trends, and then we kind of worked with the entrepreneurs over at NetScaler to define the market opportunity. And then we worked closely with them on tops of prioritizing the strategy and all of that. And at the right time, the board said, okay, we need to scale this up. So we need more experience management, and Jagadish and I took over as CEO and CTO respectively. And during that process, we kind of like understood, and we applied the same process at Ankeena, which is, I was at the time at Clearstone as a venture advisor, and we identified, okay, there's a market trend, right? So the market trend is over-the-top video is exploding, right? And that must create a need. The need was the telecom networks were not optimized. So we said, okay, we must create something that can really highly optimize the heck out of this network, right? And that was the genesis of the video delivery server appliance, which is also a software delivery appliance. And that got adopted by AT&T and Apple, you know, two radically different, huge entities. And, you know, that goes to the power of thinking, starting from the market trend. See, we don't ever start from the technology to market, not technology in search of a solution. It is always a market trend driving a need. And then how do we solve that need? Get a team that is enthusiastic about solving that need and brainstorm with them. And it needs to be their idea, not just Fabric's idea being shoved down. So it's a co-creation. That's why we call it co-creation. We kind of spend 9 to 12 months in this whole ideation process before we actually start the company. The successes have all not been equal, but I think it does increase the percentage that gets to the next level. And then there are a whole bunch of other factors come into play. So a lot of times the ratio that you mentioned is low because what I would call is infant mortality, where people are just not able to step up to that next level. They don't understand the market trends and the needs and how to translate that into something. A lot of times they start out with this, oh, this would be neat to build. And then they form a company to build it. And then they say, what's the market, right? I know one person who spent like 7-8 years just building software-defined networking in the data center space, and never did really a market analysis of what's the go-to-market, who will really buy this. just spent a lot of time just building the technology, was so enthusiastic about it, never went anywhere. So that's an example, other kind example. I would give credit to Sumant Mandal to kind of figuring this out from the Idea Labs days. And then we started two companies around the same time, the Hive, which focused on enterprise AI-driven applications. That's, of course, is huge and hot these days. And I'm quite involved with them. I can talk about that too. And then we started the Fabric in the cloud infrastructure space, both with the same similar kind of a process, co-creation process in mind. So that's what has led to, I would say, a better ratio of outcomes.
When I first got to know you, Prabakar, you were like a deep tech technologist. You were running the technology arms of one after the other. You are a senior technology entrepreneur. Today, you sound more like a marketer.
It's a very key observation, actually, because one of the key issues is really to rein in the urge to put technology first, right? Is really technology should be in service of a market need. That's the fundamental principle.
How did you, as an individual, shift from this, what we call the geeky mindset? I have this cool technology and let me do something with it, to focus on the market need and then work towards it. How did your transition happen?
I would say that really started with Exodus. So at Exodus, we were really excited about this internet technology, and the possibilities of what can be done with it, and we had all kinds of ideas. Internet delivered file system, this, that, and everything. Like Novell did like LAN file system. So why can't that be an internet-based file system? So that kind of stuff. As we went around talking to customers, a clear need emerged, right? Which was none of that. It was that the bandwidth needs are exploding, right? The scaling is just exploding. There's no way we can do this on premise, bringing internet to the premise. It has to be done at a hub, right? So that really taught us the notion that it has to be based on a market need. And Netscaler was a similar thing, which is that just like Exodus focused on the fact that in order to scale, you needed a hub, and that was Exodus Data Center. And you provide all kinds of services around that. Netscaler, again, focused on the trend that the security needs and the optimization of the server plant was, again, exploding. You have denial of service attacks, application security attacks, and just plain old encryption need, and then optimization required to deliver all of that. So we said, okay, so you need something that is a front end for the application, which is securing and accelerating the application, right? And that's the need. Now, there was a fundamental technology that people had figured out, which was the connection splitting. So basically, we applied the core technology in service of this need. And that, that's kind of like Exodus is what I would say where the mind shift took place. And then working with Sumant and Rajan and Team Ravi and all these people, we kind of like put that, the process together.
The cloud has become cloudier every day. We have everything running on the cloud lately. But do you think the cloud is resilient enough to take on the challenges posed by like generative AI, applications on the edge? There's so much going on, and we need security, we need thermal, we need power consumption. Do we have what it takes to be able to scale all these applications today? Or do you think there'll be a need for many more net scalers, if you will, or Exodus, if you will, to be able to get there?
It's kind of a virtuous cycle. I would say, which is there's a need that emerges which creates a solution, and the solution amplifies the deployment, and the amplified deployment then creates a second level need, right? And then that solution then amplifies a third level need, and etc., etc. So now, all of that has now built up to this generative AI and delivery using things like the GPUs and the DPUs and all of those kinds of things, which and the next evolution of this is going to be quantum. It will take time. Quantum is still kind of, I would say, theoretical. It's not really practical, although some people, there's hype going around, but there are quite a few challenges. But that will, that's probably the next frontier that's going to take it to the next level of all of this. But in the current generation, first of all, you had the centralized cloud, right? The evolution is taking place in kind of like different vectors. One is going from centralized cloud to a distributed cloud with the edge, right? And then centralized data to distributed data. There is data at the edge and there's data at the center. There's models at the edge and models at the center. And then the applications themselves are also getting distributed, where it is not one ball of wax. It is split into microservices that can both run in the center and at the edge, right? So this, what I would call, is the distributed infrastructure and distributed application, distributed data, combination of those. That is evolving. So that will help with scaling, right? You cannot scale with just centralization. Having the edge helps with scaling. The second, of course, is the energies that are now coming to this whole area of generative AI. It's an unimaginably fast-moving field. Okay, every day there's something new being thrown out, and these are not just the core foundational 3 or 4 large language models. This is just so many different things. There is open source models, Llama 2, it's just enormous energies, and the opening up of that has really created revolutionary speed. And then powering all of that, you have the GPUs and the DPUs and the core processor, Intel architecture, and all of that scaling up. And the cloud architecture definitely helps, because now you can bring huge processing power when you can, but also you can have a micro model and run it at the edge. So I think that it's a virtuous cycle. So as things scale up, bottlenecks will become identified. People will solve that, which will scale next level, and then another bottleneck will come, and so on and so forth. And that's been true throughout the history of the industry, and current epoch is not any different.
Yeah, you've been involved, at least that I know of, from the early days of the internet to where
Yes.
we are, whatever we call it, internet 2.0, 3.0. With this kind of explosion, I see what you mentioned, the CPUs, GPUs, DPUs, the hardware and the software cannot be separated anymore, right? So where do you think it's going? I mean, do you think for each application we'll have distinct hardware to satisfy the needs? Will we have more software-defined hardware? How is it going to pan out over time?
I think what you have is what I would term as coprocessor architecture. This used to be the case in the days of mainframes. It's kind of like what goes around comes around. Okay, it's the same thing happens in different incarnations, and maybe that's because of this virtuous cycle that I talked about. It's a spiral. Okay, so we kind of like keep coming to the same point, but at a different height. Okay, So in the IBM mainframe case, you had the central processing unit, and then you had the channel processing unit, and then you had the networking unit. These were separated and these were connected through some kind of a bus, and they each had different jobs, and things will get shunted around. Then everything collapsed into the PC concept, which was just one processor, right? It did everything, right? Then as the bandwidth started increasing and the need for shuttling around data that increased, and the need for very specialized kind of processing evolved, right? The first kind of coprocessor, I would say, that made its way into was the encryption coprocessors, right? Which was secure sockets layer. It was just impossible to do the key factoring using the Intel CPUs alone. Netscaler was exceptional at that, because we figured out how to employ an encryption coprocessor at the maximum effectiveness, right? And then people came out with this notion of smart NICs, which was kind of like a coprocessor at the interface, network interface level. And then people came up with coprocessors for storage interactions, the SAN processor, the fiber brocade and stuff, things like that. So slowly things evolved in that manner, and then now we have a world in which there are very specific coprocessors. There is GPUs for the number crunching, there is the CPU for general software, and then there is the DPU for very, very high speed packet shifting, right? Which creates the fabric in cloud and hybrid clouds, etc., right? And then I think where this will evolve to the next stage, I don't think it's going to collapse back. It's just Moore's law is at the end of its single processor tenure. I would say it continues to live on in terms of the total number of transistors that are coming into play. But as a single processing unit, like a what do you call the core, it's probably close to the end of its thing. So people are just ganging up different kinds of cores. You have the GPU, CPU cores, GPU cores, DPU cores. The next would be quantum cores. People are working on it. Breakthroughs are being made. It is slower than what many people thought, because there are some fundamental issues with respect to coherence and those kinds of things, error rates, and it's not. And also the software model has to change, which is probably the most difficult. And that will be another kind of coprocessor. I don't think the quantum will replace everything. I think initially quantum will be used as another coprocessor where specific algorithms can get accelerated, just like GPUs accelerated AI, in addition to graphical processing. The quantum, there will be certain kinds of problems that can be exceptionally well solved by quantum, including encryption, by the way. That will be employed as yet another, so maybe you'll have QPUs. So you have CPU, DPU, GPU, and then you'll have QPU as an additional coprocessor, and then we'll just keep going that way, I think.
And I thought you were only involved in the fabric. Tell us about the Hive. Hive has been going around quite a bit.
Okay. So as I mentioned, when we started this idea of co-creation, there are two parallel tracks. One was the cloud infrastructure track, which was the fabric, and the other parallel track, which I would call is the fraternal twin of the fabric, is the Hive, which was focused on data science, and AI. And now, of course, is squarely in the middle of the generative AI storm. In Fabric, we have built companies that have used the earlier algorithms, AI algorithms, that were not generative AI based, but straight various AI algorithms for virtual machine infrastructure, container-based infrastructure, and all of those kind of things. And every company captures a lot of data, and then they can now process and derive value out of it. One of the companies is now we are working on is something called CloudBrink, which is, you mentioned the edge, is distributed edge-based deployment for hybrid work, enabling secure hybrid work. So they collect huge amounts of data. So that data becomes, like people used to say, data is the new oil, right? It is. So when you have that kind of data, you can derive so much more intelligence and provide so much more insights to the enterprise customers. And this involvement has basically kind of led me to also work with the Hive, where these two intersect, kind of like the generative AI trend in the infrastructure and security, storage, networking, and all of that as it applies to that. I mean, I don't really fully understand things like generative AI in healthcare or something like that, but where it applies closer to the enterprise needs, then I can be involved with that, and I'm working with them in finding out what works, what doesn't, and helping the companies to build the right kind of solution and those kinds of things.
Prabhakar, with this kind of connectivity, a lot of people are working 24/7, and that leads to a high rate of burnout. It's easy to get sucked into being always plugged into n number of startups. How do you maintain your sanity? What do? Do you unplug?
Yeah, so I basically there are multiple layers here, right? So one layer is the fabric, which is kind of like maybe the innermost core thing that we have been doing, that we kind of like, I think, are kind of passed through that. And then the next level is working with the Hive, and then there's another similar kind of a scenario which is affiliated with Indian Institute of Science called ArtPark, artificial intelligence and robotic technology. It's partly funded by the Indian government to create new companies in the artificial intelligence and robotics space. So I am part of the core mentor group. And these are things where it's not as deep as fabric. It's more the next level of giving them, occasional meetings and advice and things like that. The third level is, I would say, promoting, all of these kind of technologies as well as entrepreneurship via educational institutions, right? So one is Indian Institute of Science, where again ArtPark is at the intersection of that IISc and the entrepreneurship, and also working with the various department chairmen there to promote entrepreneurship within IISc. And then there is this institution called Plaksha, which is in Chandigarh, which is if you know about Indian School of Business in Hyderabad, which is focused on business, or the Ashoka University in Delhi, which is focused on liberal arts, this is very similar kind of a setup. It's a private undertaking focused on technology. Kind of think of it like a private IIT. There's also the BITS Pilani, right? It's kind of like that kind of a thing. So I'm involved with them in establishing entrepreneurship and what makes things tick. And they have this program called Grand Challenges program, and what students can do, what they need to pay attention, how to do problem definitions, and all of those kinds of things. I'm working with them. These are various things, but I think you have to kind of like grade how much time you are going to spend in each of them. And you're right, there is a danger of getting sucked in, but I have managed to, I think, find the balance where how much time can be applied to what.
I see new students. There's so much going on. There's so many challenges. It's hard for students to pick a discipline anymore, because everything is shifting: hardware, software, internet, and same thing in healthcare. How do you guide young people into where they should focus, and also people in mid-career when they're making a shift in their career. How should people approach this whole problem of what's next?
Well, I think it cannot be just what's next. The career shift is a slightly different phenomenon, but from a student perspective, there is certain fundamental skills that they need to have. If they take a Coursera course and then they declare themselves data scientists, that doesn't work, right? You got to learn the math, you got to learn the data structures and the fundamentals of software engineering, how to put systems together, how these architectures are put together. Otherwise, the danger is you're going to build weekend projects and not something that really stands the test of time. People cannot take a flight of fancy and then say, oh, today generative AI is hot, I'm just going to do that. So you got to do fundamentals, and of course you can take electives in particular space and become more of an expert in that, particularly if you go to graduate studies, right? So that's what I generally tend to tell the younger kind of students, is to say get some basics right and then build. It's kind of, if your foundation is shaky, your building is not going to hold water, right? It's going to collapse at some point. So I think that's important. From a career shift point of view, that is a little tricky, because always you tend to get hired for what you already know, right? So it's almost like you have to take a calculated risk. Okay, I'm going to deliberately seek out an opportunity where I can convince someone that even though I'm not an expert at that, I can become an expert. And it doesn't come easy. It's kind of like a gravity. You get attracted to what you already know. If you are a networking expert, people will hire you for networking and not for enterprise generative AI, right? So maybe you can make stepwise shift, right? Maybe you go from networking to security built on top of generative AI, then you hop one more over. So that is something that I have told people, that make a stepwise shift as opposed to a whole scale shift, which is possible. That's a better approach.
And besides technology, Prabhakar, I've seen that you yourself have become a good marketer, entrepreneur. Do you also suggest to students and to people making these shifts to get more soft skills, learn more about the ecosystem, not just about technology?
Yeah, I wish I could say that I have soft skills. That's something that I'm quite short of. But clearly it's important. Teamwork is extremely important. People need to learn how to work as part of teams. And in fact, I'm involved with a group called IUCE, which is Universal Council for Engineering Education. So they are promoting how to teach. They are trying to train engineering educators on how to teach engineers. So in that, I've been working with them on teaching what are elements of entrepreneurialism. And one of the key things there is, in addition to risk taking, the notion of working with a team and learning from failures and learning to identify market opportunities. These are all things I think I wish I had been taught when I went through engineering courses. But I think these are some of the things that I am working with Plaksha and IISc, etc., to get as part of the curriculum, so that people are better prepared when they come out. Because in India has become a huge factory of startups. It's unimaginable the number of startups there, because India is big and the number of startups are big now, and people need to really understand what it means to survive and thrive in that environment. And yes, I would say it's very important, and it needs to become core part of the engineering curriculums.
Speaking of successes and failures, every newspaper will, celebrate successes, and many of your successes are well known. But you also mentioned that there were failures either in the portfolio companies. Tell us how we can learn from our successes as well as our failures in the process of creating anything new, including entrepreneurial ventures.
Yeah, so I kind of mentioned the process that we have learned how to increase the chance of success, but that doesn't mean that you're going to have a success. There is various grades of success I mentioned, right? But what we have learned, what I have learned is fundamental to success is that you cannot have complete control over anything, right? And building a team, putting together a team that is cohesive enough to work through all the problems and not fall apart is probably the fundamental learning. And where we have had problems have always been in not succeeding in building a cohesive team with a really good leader. So those both are very important. Having a very capable CEO who leads a cohesive team. And we have had problems on both counts, which is what has led to the not so stellar successes and the outright failures as well. This is not something that's not science. It's just art. And you have to work at it, keep working at it, and you are not going to always succeed. Sometimes luck of the draw, you're not going to end up with a good leader or a good team. So just try to identify how to find better one of those things and learn from that.
Well, Prabhakar, it's always fun to talk to you, and thank you for supporting so many ventures, educational initiatives, and may you continue to do that. And it's so important today. And to anyone listening, I'm always looking for people who are doing different things, whether it's in education, in technology, in the health sciences. We are in the midst of chaos, which means great opportunities. Let's make the most of it and let's find
Yeah.
a way to have this dialogue. Thanks again, Prabhakar.
Thank you.